A large tree is to be transported to a new location. The tree is being held vertical by means of two guy wires of unequal length on opposite sides of the tree. One of the wires makes an angle of 48 degrees with the ground. The other wire is 12 meters long and makes an angle of 56 with the ground. Both wires are attached 3 meters down from the top of the tree. So first off, let's draw that. One wire is 56 degrees with the ground, and it's 12 meters long. The other one makes a 48 degree angle with the ground. We don't know what the length of that one is, but we know that both of them are about 3 meters from the top. So we have to determine the height of the tree to one decimal place. Well, one of these triangles has two pieces of information which will be critical to find the height of the tree. We will call this H. Okay, so that normally will be your opposite of your 56 degree angle. And you've got your hypotenuse, which is 12. So opposite over hypotenuse, this is going to be sine. So it's going to be sine 56 is equal to your opposite, which I called h for height of the tree, over your hypotenuse, which is 12. So you're going to multiply those two together, and what you're going to get is 9.9. Now that's not actually the height of your tree, because we do have 3 meters that are unaccounted for. So you add those 3 meters, which means that this tree is going to be 12.9 meters. So we have to determine the length of the other wire. That's the wire right here. Here's what we've got. Redraw the triangle. It's going to be 48 degrees. The height we found is going to be 9.9. Remember, because that wire is attached 3 meters below, so we're going to use the height that we found right there. In this case, we're going to find the length of the wire. That's this right here. So we got 48 degrees. We've got the opposite side, and we're trying to find the hypotenuse. Again, what we're going to be doing is using sine. It's going to be sine 48 is equal to your opposite, which is 9.9, over your hypotenuse. Rearranging everything, you're going to have your hypotenuse equal 9.9 divided by sine 48. And when you work that out, the hypotenuse is going to be 13.3 meters. That's how long that guy wire is. Next up, we have to determine to the nearest tenth of a meter the horizontal distance at ground level between the two guy wires. So one of the triangles looks like this. It's 56, this is 12, and we said this one here was 9.9. The other triangle we said was 9.9, 13.3, and we said that this was a 48 degree angle. So we need to find the two sides right here that I'm highlighting in pink. And we're going to add those together, and we will get the horizontal distance between the two wires. So first, what I'm going to use, we need to find this side and this side right here. Let's find A. Cos 56. You can use another trig ratio if you would like, but I'm going to use cos 56 is equal to your adjacent over your hypotenuse. And your hypotenuse here is 12, cross multiply here. And what you're going to be left with is A is equal to 6.7 meters. For B, you can use cos if you like. This time around, I'm going to use tan. Tan is going to be your opposite over your adjacent. Okay, so when you rearrange that, B is going to equal to 9.9 all divided by tan 48, and so B is going to equal 8.9 meters. Now, of course, what we need to do is we need to add these two values together, and that will give you the horizontal distance. So you got 6.7 plus 8.9, and what you're left with is 15.9 13.6 meters. Next up, the guy wire in C breaks, and a new wire of the same length is attached 2 meters down from the top of the tree. Calculate to the nearest degree the angle at which this guy wire makes with the ground. So C, we found a guy wire that was 13.3 meters, and it's going to be attached 2 meters down from the top of the tree. Well, we found the tree was 12.9 meters, so this is going to be 10.9 meters. And this is 13.3. Now we need to calculate to the nearest degree the angle that this guy wire makes with the ground. Well, we've got the opposite and we got the hypotenuse, so we're going to use sine. It's going to be sine x is equal to 10.9 divided by 13.3. And because, of course, we're finding an angle, you're actually going to be taking the inverse sine of this part right here. And what you're going to find is your answer is going to be 55 degrees.